All right, so here we go. We're going to do, we're in our notes, 5.5, number 2, and we're ready for B. So, got a triangle. A is 73, and A is 24, and B is 28. And we are going to try to figure out if that information describes one triangle, or two triangles, or no triangles. I can't remember what happened on our first example. Do you have it written down? What happened? It was one triangle? Okay, so now we're going to see what happens on this one. Okay. So, everybody remember the law of sines? The law of sines says sine 73 over 24 equals the sine of B over 28. Everybody remember that? Law of sines, big deal. I mean, it's a biggie. It's important. Very easy. So then, oops, here comes another one. So then, we're going to do our cross multiply thing. And we're going to figure out what that missing angle is. Okay, so here we go. Cross multiply and divide. Now remember, sine B is going to be your variable. So we have to somehow type this into our calculator. How do we type it into the calculator when the variable is sine B? Second sine. So second sine 28 sine 73, close parentheses, divided by 24. What happened? An error. When that happens, when you get an error, that means how many triangles are possible? None. No triangles are possible. So if you were actually trying to draw this thing with a ruler and a compass, you wouldn't be able to do it. You wouldn't be able to construct that triangle. All right, let's try the next one. Okay. Now, remember, where I put my angles doesn't matter as long as I make sure the sides are matched up with them. Alright, so here we go. Same thing. Sine 32 over 10 equals sine A over 18. That okay with everybody? Alright. So now we're going to type, well, I'm going to solve for sine A. So sine A is going to equal 18 sine 32 divided by 10. So again, that's sine A. So we'll second sine 18 sine 32, close parentheses, divided by 10. Oh, I got an answer this time, did you? And the answer that I got was 72.53. So now, do you remember from last time? What do we do now? Immediately we what? Draw it again. Draw that same triangle again. So 32, 18, 10. And then for angle A, we check to see if there's another possibility. The other possibility is always 180 minus the first possibility. So the first possibility was 72. So this possibility is going to be 107.47. And then we stand back and say, okay, does that triangle make sense? Is that possible? And the answer is yeah. What happened yesterday, or whatever day that was? Yesterday. What happened yesterday when it wasn't possible?
There's only one child.
Well, yeah, because why? Because these two added up to more than 180, right? So if I would have done my subtraction, and instead of getting 107, I would have gotten 157, then you would have said, no, that's not possible. You can't do that. But as it is, they're both possible. Okay? All right. So now what we're going to do is, I don't want to make too big of a deal of this, but let's go ahead and just to see how this works, let's go ahead and finish solving this triangle. So this is problem C, and I don't know if you noticed or not in the directions, it was how many triangles were possible and then solve them. So let's go ahead and solve this one, letter C, and we're actually going to have to solve twice because there are two possible triangles. All right, so everybody understand what we're doing now? We're going to finish the project. We started it, we figured out we got two of them, now we're going to actually solve them. So I'll start with this one right here. This was our first case. I'm going to solve that triangle. Now, I already have everything except angle B and side B, right? So tell me about that.
You can find angle B by
Okay. Exactly. Angle B is going to be 180. I'm in this triangle. I'm doing this one right here. So that's going to be 180 minus 32 minus 72.53. 75.47. Perfect. And then how will I find side B? Exactly. And I love that Jesus is going back to the original given information. No round off here. He says I'm using 32 and 10. And that's going to equal the sine of 75.47 over B. So then we'll cross multiply and divide. Will I be second signing on this one? No, because my variable is B. I only second or inverse when it's sine B or something like that. So here we go. 10 sine 75.47 close parentheses divided by sine 32. I got 18.27. So the first possibility is now finished. Would everyone agree with that? Now, guess what we get to do? Same thing, only we're doing it with this triangle now. Okay? So what's the first thing you're going to notice about this triangle? Let's see. We can find that angle B. So that would be, yeah, probably, I don't know, 107.57? 47. 40.53, is that what you said? And then we have to find the other side B on this triangle, our second triangle. And what we do it exactly as we did over here, but we'll use 40.53 as our angle. So still falling back on sine 32 over 10, but now sine 40.53 over B. Yep, 12.26, perfect. All right, when does all this, again, one more time, when does all this, how many triangles are possible, when does that happen? No, it can happen, it doesn't happen in every non-right triangle. It happens when you have angle, side, side given. Yeah, when angle, side, side is given. Remember, the given here was the 32, the 18, and the 10. That's angle, side, side. That's what causes us the problem, the potential of 2. All right, good deal. Now we got some word problems, it looks like. Let's see if we can sort these out. All right, so here we go. We've got, well, the picture's drawn, so that's okay. And this is 28, and this is 37. This is 2.32. A, B, C, I guess. And what do I want to know? The altitude of the balloon. So, isn't that what I want to know? Okay, now wait a second. Let's think about this for a second. When I drop that altitude, now I have a right triangle, and remember in a right triangle, you're allowed to Pythagorean Theorem, SOHCAHTOA, and all that. Here's the problem. I do not want you to assume that this thing cuts this in half. This is not an isosceles triangle, so these two pieces aren't equal. I know the whole shebang is 2.32, but I do not know either of these individual pieces. Does that make sense to you? If I focus then on the right triangle, either one, doesn't matter, let's say focus on this one, I don't have enough information about that triangle. Because while I know all three angles, I can find that one. While I know all three angles, do I know any of the sides of that right triangle? And without the sides, a side, you can't find the others. Same thing over here, would you agree? So here's what we have to do. Let's take that out for a second. Remember I said I didn't have any sides of this right triangle? Could I find this side right here? Well, I'll call it A. Could I find side A? Would that be possible? And then once I knew side A, could I drop that altitude back in and then work in that triangle? Yeah, so you understand? 2 steps. Okay, here we go. So how am I going to go about finding side A? Find angle C, and that'll be easy. Right? 115. And then what? Now that I know angle C. Boys, are you still there? I don't see either one of you. Why are you laying down or doing whatever you're doing over there? Now I see you, thank you. All right, so sine 115 over 2.32 equals sine 28 over A. Now, I just randomly picked A. Could I be doing the same thing over there for B? Yeah, it doesn't matter. We gotta find one of them. All right, so what's A? Let's see what A is. Tell me what you get. Yeah, it's a small one. That's okay. 1.20. Perfect. Beautiful. Now that is side A, not the answer to the question. The answer to the question is this. Now here's the cool thing about the law of sines. We could say sine 90 over 1.20 equals sine 37 over x. We absolutely could do that. The law of sines works in every triangle. But because that's a right triangle, you could also just say sine 37 equals opposite over hypotenuse. And that would also work. And these are going to give you exactly the same answer. So you can do whatever you want. So it looks like our answer is 0.72. And that probably has a unit on it. Miles? So the answer is 0.72 miles. Does that make sense to everyone so far? Easy enough? All right, let's try the next one. Two meteorologists are 25 miles apart, located on east-west road. So it's like it might be involved here. Let's see. So we've got, here's our east-west road, and here are two guys. They're 25 miles apart. Meteorologist at point A cites a tornado. Okay, so they're kind of doing the same thing. They're looking up here at a tornado. There's the tornado. Let's see, I guess they called it. And this one's 38 east of north, and this one is 53 west of north. Now, luckily they do the picture for us because we've never really talked about that vocabulary. But does it make sense to you? Well, first of all, this is a north-south line, right? Does it make sense to you that if I'm 38 degrees east of north, that it would look like this? And then 53 degrees west of north would look like that? Okay. Find the distance from each meteorologist to the tornado, and then find the distance between the tornado and the road. So we have to find side B basically and side A. That's the distance from the meteorologist to the tornado. And then when we're done with that, we'll drop that altitude back in and find it. All right. Do you have a plan? Remember, this was north-south and this was east-west. So if that's 38, you can figure that this one is 52. And likewise over here, if that's 53, then this one is 37. Which makes this one up here what is it? 91?
Yeah.
So let's find A and B. I think you know how to do that. Then you sine 91 over 25. And unfortunately, you're going to have to do both. You're going to do it twice because you can't use the Pythagorean Theorem or anything like that. So you're just going to have to do your law of sines twice. Caleb, are you there?
Yeah, I'm here.
All right, so here we go. I got 19.7 for A. And if you didn't get that, you need to speak up, people. I got 15.05 for B. Okay, now, how high is the tornado above the ground? I'm going to drop an altitude down. Don't make any assumptions. You can't. There are no assumptions to make. That's not split in half. This isn't split in half. Nothing's split in half. But we don't care because we already know this side over here. So we can say sine 37 equals x over 19.7, opposite over hypotenuse. Or we can say sine 37 over x equals sine 90 over 19.7. Either way you want to do it, it doesn't make any difference. The law of sines works in every triangle. I mean, it's true, I should say it's true in every triangle. So, what did you get?
11.86.
Yep, 11.86. And that's, what's that unit? Miles again.
So, like the first problem, you know how we only have to do one side but not the other side? So I guess I'm a little confused why we have to do both sides.
Because that's what the question asked for.
Oh, okay.
It said find the distance from the meteorologist to the tornado, for each meteorologist to the tornado, right? Yep, so we just answered the question. All right, one more, here we go. Looks like they drew the beautiful picture for you. So let's take a minute and have you try number 5 on your own. Check your answer with a partner. I think it's a two-parter also because I think they're asking you for 2 distances. 2 distances. I know the picture is there, but if it weren't, would you still be able to draw it? Does everybody remember when it says that angle ASB is 33 degrees? You know what that means, right? A to S to B. So A to S to B. So you would put your 33 there? Okay. I'm going to wait and see what you get. I'm going to do it on my own paper. Boys, you need to be doing this. Ray Straley, you got him? Hector, you got him? You awake or asleep back there? All right. Stay focused, right? Jessica, what about you? You getting them? Yeah. Rory, you got him?
I think so.
You think so? All right. Jesus, pressure's on. What did you get?
For side B, I got 36.58 miles.
So, that's this one?
B, that top one.
This one?
Yeah, 36.58.
I think I like that's not mine.
I think you may have messed up.
Yeah, that's
Twenty.
no, I like switching my variables around.
Yeah, just,
Yeah, my variables are like different.
Well, wait.
okay, so the one across from side A, or across from the 95 is 36.58, and what's the other one?
28.94.
Beautiful. Beautiful. All right, so right there, that was a little quiz, and you all did it perfectly, so that's good. All right, now we're moving on to the next page, and we'll probably take another little quiz here in a minute. But all of a sudden now, things are gonna be a little bit different. I'd like you to look at this triangle. And again, I've got three things, which is what I need. As long as you give me three things, not all angles, I can't do it if you give me just the angles, but as long as you give me some mixture of angles and sides, I'm good. But tell me about the law of sines here. What's going to happen if you set up your law of sines? You can set it up, but what's going to happen? You don't have a pair. By the way, I'm going to drink Coke when I'm very stressed. Today's very stressful. I don't have a pair. In order for the law of sines to work, remember, this is what the law of sines proportion looks like, right? You're only allowed to have one variable. It's not solvable with two variables. So if you're only allowed for one of these to be blank, then don't you have to have that complete, don't you have to have one of them be complete? So we don't have that in this case. When you don't have a pair, it isn't that the law of sines isn't true. It's true all the time. It just isn't solvable if you don't have a pair. So the first thing, when somebody throws a triangle at you and says, solve this triangle, the first thing you do is check to see if you have a pair. If you do, you're going to jump in with your law of sines, because there's nothing easier than the law of sines. If you don't, then you're going to have to go to the second law, which is the law of cosines. So if we don't have a pair, we're going to use the law of cosines. Now, it's going to look really big and scary, but I promise you, in about 30 seconds, you're going to be whipping it off like crazy. The way the law of cosines works is, whatever angle you're using in the problem, which for us is this one right here, that's going to go right out here at the very end of the equation. So at the end, I'm going to be writing an equation here in a minute, and at the end of the equation is going to go cosine angle. In the law of cosines, you will only use one angle. If you have two angles given, you're going to do the law of sines, okay, every time. If you only have one angle, then that's what's going to go out here at the end. At the other end of this big long equation is going to be the square of the side that matches that angle. So if I'm putting angle C out here at the end, cosine 58, then I'm putting side C down here. If I were using cosine S, if I knew what S was, then this would be S squared, okay? And then everything in the middle is a combination of these two sides. And it comes straight from the Pythagorean Theorem, and it looks like this. 10 squared plus 12 squared minus 2 times 10 times 12 times the cosine of 58. Now, I told you the first time you looked at this, it would be scary looking. Don't be frightened. It's always set up exactly the same way, okay? So just for fun, let's step aside real quick and let me throw another triangle up here, and let's see if you can set it up. This is a totally separate triangle. Just chill out for 16 minutes, or for 16 seconds here. What would this look like if I wanted to find side A? I'd have A squared here, and what would I have out here at the very end would be cosine 74. And then everything in the middle would be 16 squared plus 10 squared minus 2. That's part of the formula. That's always there. Minus 2 times 16 times 10 times cosine 74. That's how it works. Okay, it's that easy. Now, the good news is, back to our problem here, that was extra. That was just an extra. back to our problem. The good news is your variable's out there all by itself, so you can just type it in. Just type it in. So 10 squared plus 12 squared minus 2 times 10 times 12 times cosine 58 equals. Notice I didn't put any parentheses in, I didn't hit any equals, I didn't stop, I didn't move down, I just typed it all in. What do I have to be careful of now? What's that number? That's c squared, right? So 116, that's c squared. So what do I need to do? Square root. So second square root, second answer. And you should come up with 10.81. Is that what you got? Now remember, the directions said solve the triangle. So take a look at that for a second. Solve the triangle. What can I do now? Now I can do my law of sines. Because see what I have now? Right? Didn't have that before, but now I do. So now I can jump in and do my law of sines. So what's that going to look like?
Sine 58 over 10.81.
Yep, sine 58 over 10.81 equals
Sine 7.
sine h over 10. Could I also do sine s over 12? Yeah, it doesn't make any difference. Whatever you want to do is fine. Okay, so here we go. This is sine h equals 10 sine 58 over 10.81. So what do I have to type to do that one? That's going to be a second sine. 10 sine 58 close parentheses divided by 10.81. So 51.67 is h. And then how about that last one? Let's just subtract from 180, right? We could do the same thing, but that would just be more work than necessary. Once you've got two angles, can't you find the third one by just subtracting? So 70.33. If I subtracted right, did I subtract right? Is that okay with everybody? All right, let's look at the next one. Yep.
When you added those two, what did you get? When you added 68 and
51.67, 109.67.
oh, and then you subtract that from 180.
Sure.
Okay, I thought it was
To get your third angle.
Yeah.
All right, let's look at the next one. This one looks different yet. Didn't draw it for you. Notice those are all lowercase letters. What does that mean? They're the sides. So this time I know all the sides, but none of the angles.
You have to go backwards with that equation?
So am I going to be able to use the law of sines? No, absolutely not. It's going to have to be a law of cosines problem. Now, when you have no angles at all, most of the time it isn't going to matter, but occasionally there's a little bit of room for some ambiguity, unfortunately. It doesn't seem like there should be, but there is. So when you have all three sides, you know you're going to use the law of cosines. I would suggest that to avoid any potential issues, you find your biggest angle first. Your biggest angle first. So how do I know which is the biggest angle? The biggest side. So that's going to be angle H. Now again, this happens occasionally. I mean, you run into issues occasionally. Not very often, but occasionally. And this way we just won't ever have to worry about it. Just find your biggest angle. So we're going to find H. So that means out here I'm going to have cosine H. Remember, the law of cosines has one angle in it. We picked H, cosine H. That means on the other end of this equation will be 7.6 squared. Right? Because that's side H. And the equation is bookended angle side. And then everything in the middle is going to be a combination of these guys, right? So 6.4 squared plus 3.2 squared minus 2 times 6.4 times 3.2. And that's all times the cosine of H. Now this one is not as easy to type in because the variable is not over here all by itself, it's kind of in the mix here. So we're going to have to be doing some solving, some regular solving, like moving things around and stuff like that. My personal preference is that we start by just doing this basic arithmetic and getting this stuff cleaned up. So I'm going to have 7.6 squared, which is 57.76, 6.4 squared, which is 40.96, 3.2, and then all of this is multiplied. So I'm going to go ahead and do 2 times 6.4 times 3.2, and that's 40.96. Cosine H. All right, so this is our first time ever doing this, so let's make sure everybody's still on the same page. Now, can these two be added together? Yeah, so let's do that next. So we have 57.76, and that's going to equal 40.96 plus 10.24. Which is 51.2 minus 40.96 cosine H. Now, can these two be subtracted? No. And that right there is the biggest mistake kids make with this. That does not subtract because this one's hooked to a cosine. So what am I going to do instead? I'm not going to divide yet. What am I going to do first? Do I want to move this over to here? So 57.76 minus 51.2, so 6.56 equals negative 40.96 cosine H. Now I'll divide. So cosine H equals 6.56 over negative 40.96. Now, let's not actually divide that, or if you want to, that's okay, but don't write it down and round it off, because it causes big time round-off error. This is the cosine of angle H. Would everybody agree with that? So, I'm not going to type that by itself into my calculator. What am I going to type into my calculator to get angle H? Second cosine. So, I'm just going to second cosine that fraction, and then I won't have to worry about it. You do need to put the negative in. You do need to put the negative in. And that should give you angle H. What did you get? 99.22? Is everybody okay with that? Could we now do exactly the same thing for angle S? Yep, what else could we do though if we wanted to? Now we can use the law of sines. And for those of you that are worried about round-off error, I'll address that in a minute. first I'm gonna erase something here. Everybody's okay with everything so far? All right, so now let's set up our law of sines, because we just like it better. It's so much less cumbersome. You want to find s, so sine s over 64. If you are worried about round off, which is a legitimate concern, let me remind you, let's get to this point first. Everybody ready to put it in? Remember, the last thing that came up on your calculator was that 99, right? So let's just type 6.4 sine answer, close parentheses, divided by 7.6. And then guess what? Oh, I forgot the second sign, so now I have the second sign, second answer. Here we go. Did you get 56.23? So if you are worried about round off, go ahead and use this number as it's on your calculator. So 6.4 sine second answer divided by 7.6. You still have to close the parentheses. So 56.23 is what I got for S. And then for C, I will just add those two and subtract from 180. Ooh, 24.55. And you have solved the triangle. Okay, just a couple more things here. Let's try C, problem C. First thing you gotta do is draw a triangle. Make sure you get things lined up the way they're supposed to be. I'm not sure why I have C's and P's when I'm supposed to have. Okay, I guess this is triangle ABC, not CHS. C is 57, C is 11, and B is 10. Wait a minute. There's a match. However, don't forget about what we talked about earlier. There's a match, all right, but what? It's angle, side, side.
Isn't that law of sines?
We're going to use the law of sines, but we're going to have to check to see if there's another answer. I mean, this might come up no answer, but because it's an angle side side, that will never happen with your law of cosines. But when you've got angle side side, when you see I got a match and that other side, that's trouble, maybe. So here we go, sine 57 over 11 equals sine B over 10. Is that the way you would start? Second sine 10 sine 57 divided by 11. I got an answer, did you? Yeah, so this angle B is 49.68. So that means I need to check to see if there's going to be another angle B. Does everybody understand why I'm doing this check? Because of the given, right? So it's angle B, and the other one would be minus 180, 130.32. That's not possible, is it? So luckily, I don't have to solve twice. I only have to finish that problem. So I'm solving the triangle, so I got to find everything that I need. So what are you busy working on there, Grace? I see you typing away. What are you working on?
I added them and then subtracted by the.
And that need your angle A?
Yeah.
And what was it?
73.32.
Okay. Everybody in agreement with her there? All right. Now now what? Only one more thing left to find, and that would be side A. So go ahead, I guess we'll do law of sines again. Okay, Jessica, this one's gonna be yours. All yours. Shout it out when you get it. It is! Woo! There's another quiz question. Yes, Jessica, good job. Your classmates love you. Perfect. What I want to point out, guys, is that these random, weird ASS things can show up when you least expect it, so be on the lookout for that. If you set up your law of sines and your variable is an angle, you probably have issues. So stand back and take a close look at it. Okay, all right, one more thing. Finding area. Finding area. So, when I say find the area of a triangle, what pops into your head? 1/2 base times height. And that is magnificently wonderful. That's what we use. The problem is, let's see what we've got here. We've got angle A is 47, side B is 32, and side C is 19. Now, if I were to draw a height into that triangle, would you agree that it would or could look like that? There's actually 3 altitudes, but that would be one I could draw in, right? That does not split the base. The whole thing's 32, but I don't have any idea how big each piece is. Could I find H? I actually can, because in this right triangle right here, can I say either sine 47 equals H over 19, or sine 47 over H equals sine 90 over 19. Either way, I can find that, right? So let's do that real quick. Let's say sine 47 equals H over 19. So H equals 19 sine 47. Now don't type that in. Just agree with me, hopefully, that that would be one way of expressing H. So then when you said my area was 1/2 base, which would be 32, times height, which is 19 sine 47, that would be how to find area, right? I want you to look at this for a second, guys, because next time I'm not drawing that purple line. Because what ended up happening? What did I end up, let me take that purple line out of there. Pretend none of that happened. To find the area of that triangle, ultimately, what did I end up doing? 1/2 side, sine of included angle. And by included angle, I mean the angle that's between the two sides. That is your first new area formula. Your first new area formula is 1/2 side, sine of included angle. We call this, when we talk about it, 1/2 side, sine. 1/2 side, sine. That is your area formula. So it is super simple. You just type in 1/2 times 32 times 19 times sine 47. and your area is 222.33 square feet. Okay? I promise, 2 more problems and we're done. Let's look at B. So what do we have? Given. You know, angle A is 43. Angle B is 57. And side B is 12. Oh, crap. This one's not as easy, is it? It would be if I knew this side, because then could I do 1/2 12 that sine 43? Can I find that side?
Yeah.
How?
Finding angle C and angle B.
Exactly. I'm going to use my law of sines to find that side, because I can figure out that angle is what? 80. So sine 57 over 12 equals sine 80 over C. So I can figure out what C is. So 12 sine 80 divided by sine 57. Did you get 14.09? Okay, so this is 14.09. So now look at what you have right here, guys. Now you can say your area is 1/2 12 times 14.09 times sine 43. Does everybody agree with that? 1/2 side, sine. Now when I type this in, I'm going to minimize round off. That number's in my calculator, right? So I'm going to type 1/2 times 12 times second answer times sine 43. And that way I don't have any round off there. 57.66 square centimeters. Did I do that right? Okay. One more. Remember a minute ago I said we're going to get 2 new area formulas? Here's the second one. I know that you could find an angle. This is all 3 sides. Those are all little letters. It's kind of hard to tell on the C, but they're all little letters. You could find an angle. We did that a little while ago. What law would we use to find an angle? Cosines. And if you found, I don't know, from angle B, then you would do 1/2 side, sine B, right? And that would be done. There's an easier way. There was a really smart guy a long time ago named Heron of Alexandria, and he came up with what we call Hero's formula. This is called Hero's formula. His name was actually Heron, but it's Hero's formula. And it looks like this. It's a big radical. And underneath it, it has 4 things. 4 numbers underneath that radical. I bet you can guess what that little a, b, and c stand for. The sides. So what is this S? Well, S is what we call the semi-perimeter. What do you think semi-perimeter means? What's a semicircle? Okay?
I don't know, but what's the first? Is that an S or a 5? The very first outside of the.
That's an S. These are all S's. What's a semicircle? Half a circle. What's a semi-perimeter? Half the perimeter. So what is the perimeter of that triangle? Add them all up.
38.
38 divided by 2, 19. So your perimeter was 38. So your semi-perimeter is 19. So to find the area of this triangle, it is so slick. This guy was brilliant. 19, start with the semi-perimeter. Then do 19 minus each side in whatever order. The order doesn't matter. So 19 minus 10, 19 minus 12, 19 minus 16. And you type it all in, take the square root, and that, my friends, is the area of the triangle. 59.92 square centimeters. So, going forward, when we find the area of a triangle, we're going to think about two things. If we have all three sides, we're going to go straight to Hero's formula. If we have some sides and some angles, we're going to focus on 1/2 side, 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 right? And sometimes we have to find something missing in order to do that. Okay? All right. Perfect. Wonderful.